Laura Flores and John Cortizos.
Thank you. Hello, everyone. My name is Laura Flores. I'm going to present you this work that I've been doing with Jean Cortizos. So it's called Probability Density Function for Predicting Productivity in Masonry Construction using the compatibility of the crew. Okay, so the problem statement is basically, the foreman in the job site, first thing in the morning, he has his group of workers, and these workers may have different characteristics. So these workers have different skills, have different capabilities, even different personalities. So how can that foreman select the most appropriate workers to form the different crews so that those crews at the end maximize productivity? That's what every foreman wants to have in the job site. So the objectives of this study is basically, the first one, the idea was to identify the factors that are considered informing crews in masonry construction, and then propose a productivity density function in terms of the compatibility of the crew, and use this to better estimate times of construction and crew formation strategies. So one of the limitations about this study is that some other technical aspects that may impact productivity are not going to be considered, and some other social aspects as well, and you're going to see further on. I'm going to explain a little bit more about this. So I spent a lot of time in masonry sites, more than a year, and talking with foremen and different superintendents across the United States. And one of the things that I found, and it was a consensus about all these foremen, was that they make up crews with people that get along very well. That's the main factor, people that are compatible. So that was very interesting to find out that that was a key thing that they use for forming people and grouping people in crews. So with this idea in mind, we're proposing a framework to basically use that and as a way to just see if we can actually predict productivity using that compatibility of the workers. So the first one that we're trying to define is okay, we're gonna have a data input module, and basically we wanna use a test to measure personality of the workers. So then once we measure the personality, then we have a measurement module, and basically with this one, we're gonna measure personality, we're gonna define if there's a way that we can actually quantify the compatibility between the workers and see if actually, people that get along well are actually more productive than people that don't, or see what's going to happen with this formation. And then also get some productivity rates and see if there's a link between those productivity rates and the compatibility of the crews. And then with those metrics, then there's a function module, and basically we're going to try to define a probability density function that will help us estimate productivity, and using compatibility as your x variable. And then with that, then we're gonna have a reporting module, and basically this one will help us determine times of construction and also better have productivity estimates of different crews, and then also provide the foreman with crew strategies to form better crews in construction, and maybe give some tips of how do they should they assemble the crews on the site. So this is the labor productivity function, and then like I said, we're going to assume that the crew formation strategies are based on the compatibility of the crew. Okay, so we're using compatibility, and we're saying that is going to help us determine the productivity. And then with the compatibility, you basically are going to be able to estimate the time that the crew is going to take to build a specific wall, and then with that time you can estimate the productivity of the crew. So we're assuming that productivity is going to be a function of compatibility, and this function is going to be increasing in its arguments. So by this I mean with a higher compatibility, we're going to have a higher productivity of the crew. And then in a more general context, we can write this as the function of productivity is going to be in terms of the compatibility by some constant, and then we may have some other factors. I don't know, we may have skills, we may have craft, we may have suitability, and all of these constants might be different. So then we're saying, okay, this is our function, and it's going going to be in terms of compatibility and that specific constraint, and then we have some other factors. But just for simplicity here, we're assuming this function is going to be just in terms of compatibility. And we're assuming that this productivity function may have a universal shape. So let's think about, we can have a productivity compatibility function that is convex, or we may have one that is concave. Okay? So what we're assuming, without any other knowledge, we're going to assume that this is going to be concave. So the assumption behind this is that, there's going to be at a certain point that you increase compatibility as much as possible, but there's a certain maximum productivity that you can reach. We're all humans. These workers are humans. So even if you pair people that are amazing together, there's a certain limit on the productivity. So that's why we're assuming this is going to be concave. And if we're assuming this is going to be concave, then that equation above below applies, and this will satisfy this equation. And then we may say, okay, this is going to be maybe a continuous function, or compatibility could take values on a discrete scale. We don't know yet, but we're basically saying, okay, this is going to be concave, and that's going to hold for all the values. So if we look at closer here at the concave shape of the compatibility function, then the shape might have implication on how the foreman chooses the crews. So let's say, for instance, if the foreman has crew 1 and crew 2, and he has the compatibility, you see that the difference between the productivity of crew 1 and crew 2 is way much higher than the difference between the productivity of crew 3 and crew 4. So if the foreman has, in the first instance, crew 1 and crew 2, definitely he's going to choose crew 2 over crew 1, and crew 4 over crew 3, but you see that the difference doesn't make sense, so there's not much difference between those two. So the foreman might try to find crews that, with a very small difference in compatibility, then the productivity is going to be way much higher. And as you see here in this function, there's also a value of compatibility, and here we call it CO. That value pretty much determines crews that have a compatibility higher than CO, then pretty much the difference on productivity is going to be very small. So we're trying to concentrate on crews that have values that really make a difference in the productivity. So it would be interesting to find that CO value. So what we're proposing here is basically a way to predict productivity. Let's say, for instance, we have an example. We may have two walls, and we have wall 1 has to be finished before wall 2. So we may have a productivity function that estimates the time that it takes to complete wall 1, and then we may have another function that determines the time that it will take to complete 2 walls. And then with experiments in the field and measuring productivities for different crews, we may find the mean time for building wall 1 and for building wall 2, and also the variance for building these two walls. So in a more general context, we may find that we can actually have a probability density function of the time that it will take to complete wall 1 and wall 2. So here will be our productivity density function, and basically that will help us be more precise about the time that it will take the crews to finish each of the walls. And also with this, we may have strategies on what are going to be the masons that is working in each of the crews and in each of the walls, and also the time periods that these masons are going to be working in each wall. So to conclude this work, we're proposing a new labor productivity function in terms of the compatibility of the crew. And this function, the idea is that it will support the superintendent when selecting crews in the job site. So like as I explained, the idea is just to see what are the best strategies that actually work to increase productivity. And the shape, as I show you, can help understand what aspects, for instance, may influence crew formation and what should be the focus of managers and superintendents when forming crews, and this may apply to other teams. So basically, these hopefully we can find a way to generalize this and actually support superintendents in what should be the focus. Should they focus on crews that are very, very compatible, but actually their difference is not very high? Or should they just like find a crew that, has a good compatibility, has a good productivity, and if he has the decision of choosing between both, then it's not going to be so stringent, the decision of selecting these crews. And like I said, one of the limitations about this methodology is that here, for simplicity, we're assuming that productivity can be predicted considering the compatibility. I know there's some other factors that influence productivity, skills, maybe the type of craft in the wall, maybe how suitable a mason might be working in a difficult wall or a simple wall. But we're just exploring this side of compatibility between the workers in the crew. So thank you very much. Yeah, very good question. So we're basically there's some personality tests that you can use. So I know one of is the Belbin test. There are also some theory behind the big five dimensions of personality. So basically, each worker can have a profile of each personality, and basically you can quantify a way and determine their personality characteristics. So that would be the way. Initially, what I did was actually asking the foreman to have the crews and pretty much determine, okay, these workers, are they compatible or not? And they use a discrete scale. But now it's more what I said, so using tests and more precise, that measure of the personality.
I'm not sure if I understood the compatibility is between the worker, individual worker, and the task, or it's among the workers?
It's just among the workers.
Oh, I see.
Mm-hmm. Yeah.
So really, if people with a similar personality would be most compatible, or is there a possibility that the opposite happens?
That's what I hope I find.
Hi, I'm Lenny from University of Alberta. So I saw that when you determine the probability function of their productivity, you use mean and variance to determine the probability, right?
Mm-hmm.
And that's based on normal distribution. But the problem of using that is that theoretically you can still get negative productivity from your distribution. So when you sample a productivity from your distribution, how can you avoid that?
Sorry, what was the question? How can I avoid?
How can you avoid sample a negative productivity from your distribution?
Well, you can actually, use like a, how you call that, like a way to just you're kind of like displacing. You can not, it's kind of like displace the value so that you can actually get avoid that problem of the negative values.
So you mean controlling the distribution?
Yeah, yeah, yeah.
My suggestion is that maybe you can look into beta distributions to fit this.
Okay. Thank you.
Hi, I'm Lori Cavadas. Question: do you consider all subcontractors equal? In the sense, like, you have, does it matter, for example,
Well, to be honest, I've only looked into masonry, and but I guess it will be interesting to look into. I mean, you're saying compatibility between different subs and between the with the general contractor as well.
I'm saying, does it matter if the painting proves compatible with regards to the productivity as opposed to a masonry as opposed to a?
I have no idea. I guess that will be an interesting finding, but I don't know.
I have a question. You said you used ocean, right? The personality test that you used. Why did you choose that method? That test.
Well, because that test, I mean, it's been proven in other studies with human resources, and it's one test that helps you, I mean, pretty much define characteristics and of the people, and it has been used in different, different industry sectors. So that's why we thought it will be useful to use it in this case.
And another question that I have is, have you considered doing the reverse approach, studying a crew that has a high productivity and then trying to understand their personality?
Yeah, so, well, here we're not trying to understand their personality. We're just trying to find if there's a link between that personality and the productivity. So definitely, yeah, we're gonna link that and see, like a group that is very productive, see what's going on between those workers that belong to that crew.
There's a correlation.
Yeah.